Hello everybody, today we are going to talk about using the Pythagorean Theorem, one of the most useful of all the theorems. Okay, so first we're going to start with the converse of the Pythagorean Theorem. So what's a converse? So if I have a theorem that says if A then B, the converse is if B then A. Okay? So we had the theorem that said if the three sides of a if a triangle is a right triangle, then the Pythagorean theorem a squared plus b squared equals c squared works. Well, this is saying if the equation a squared plus b squared equals c squared is true for the lengths of a side of a triangle, then the triangle is a right triangle. So that's how you can tell if something's a right triangle. Okay, I saw this once really great. My brother did this. He was building a treehouse, okay, and the floor of the treehouse looked like this, and he wanted to make sure that this was a 90-degree angle right here, exactly. And so what he did was he measured 3 feet this way, and he measured 4 feet this way. And then, from this point to this point, he made sure that that was 5 feet exactly, and then he nailed the walls into the floor right there. And that 3, 4, 5, remember 3 squared plus 4 squared equals 5 squared, so 9 plus 16 is 25, 25 equals 25, right? So that guaranteed that was going to be exactly a right angle there, and you want to make sure that the corners of a building are perfectly square. Okay, and that was the way that he could do it very easily. Okay, so what we're going to do here is we're going to check to see, are these two things right triangles? All right, so here we go. We're going to say, okay, well, is 9 squared plus 40 squared equal to 41 squared? Okay, well, this is 81. I'm sure you all knew that. This is 1600 right here. That's pretty easy to do in your head. Now, 41 squared is a little tougher, but you can do that on your calculator if you need to, and that comes out to be 1681. And you add these together and you get 1681 equals 1681. So that tells you, yes, that is a 90-degree right triangle there. So you can say this implies it's a right triangle. Okay, now let's check this other one. So here we would go 12 squared plus 18 squared should be 24 squared. This is 144. I think that's 324 if I remember right. 18 squared, yes, is 324. And I believe 24 squared is 576, but we'll check that. Yes, it is. Okay, so those two add up to 576. 324 plus 144, nope, that's 468. Okay, so we know this is not equal to that, so that implies it is not a right triangle. And that's a terrible triangle, so we're going to do that again. Okay, still not great, but we're going with it. All right, so now, here's what I want you to do. I want you to check these two on your own. See if they're right triangles, okay? So pause the video, check those out using the Pythagorean theorem, then jump back on and tell me if it works. Okay, so here we're gonna, okay, so you always, the two smaller ones always have to be the two legs. So this is gonna be 20 squared plus 21 squared has to equal 28 squared. Doesn't matter what order they're in, the biggest one is always the hypotenuse. All right, so that's 400, and that's 441. Okay, 28, whoops, 28 squared, I don't believe, is going to be 841. It's 740. 84. Okay, so this is not equal, so that implies it is not a right triangle. All right, now let's check this one. So this would be 0.75 squared, we have scary decimals, plus 1 squared should equal 1.25 squared. Now be careful, these are in millimeters right here. Make sure they're all the same units, okay? So let's see, 0.75 squared. That's 0.5625. That's just 1, that's easy to do in your head. 1.25 squared is 1.5625, and I add those together and I'm going to get 1.5625. So yes, it is a right triangle. So there you go. All right, the distance formula. This is a super important theorem right here too. The distance formula is just the Pythagorean theorem in disguise. Okay? So, let me just check here real quick. All right. So, here I have a point right here, and I've got another point right here. Okay, this is the point x1, y1. This is the point x2, y2. This looks like a slope triangle, right? We did this with slope. Okay, now, this is the point x2 because it has the same x coordinate as this one, and it's y1, it has the same y coordinate as this one. So, if I want to know the distance here, the x coordinates are the same, so I can't do anything with them, but I can subtract the y coordinates. So this distance right here is y2 minus y1. And this distance right here is x2 minus x1. Okay, now I can do the Pythagorean theorem on this, right? So, the leg squared, x2 minus x1 squared, plus the other leg squared, y2 minus y1 squared, equals the hypotenuse, which is d, squared. Okay, now I don't want this. Here's what I'm going to do. I'm going to square root both sides of this thing, and the square root of d squared is just d for distance, and that's equal to this, the square root of x2 minus x1 squared plus y2 minus y1 squared. That's my distance formula. And yes, I would expect you to know that. Okay, you're going to use the distance formula a lot. Okay, so find the distance between 1, 5 and negative 4, negative 2. So the first thing you're going to do is you're going to write down your distance formula, because that's what we always do. We write down our formulas. Okay, 1, by writing it down over and over and over, it cements it in our brain. And 2, it shows us where everything goes. Okay, now it might be convenient for you to label these. This is x1, y1. This is x2, y2. Okay, and so now we can plug things in. D equals the square root. Okay, so this would be negative 4 minus 1 squared plus negative 2 minus 5 squared. And now I just figured it out. I mean, once you get here, this should be easy now, right? So D is going to be, let's see, negative 4 minus negative 1 is going to be negative 5 squared. And this is going to be negative 7 squared. And then, let's see, this is going to be negative 5 squared is 25. And that's going to be 49. And then that's going to be 74. Yep. Okay, and the square root of 74 would be approximately 8.6. Now, here's what I would do. I would box that up just like that. Because now you got the exact answer. That's the exact answer right there. People think this is the exact answer because it's got a decimal, but it's actually not 8.6. It's 8.602325267, and who knows what it goes on after that. Okay, so this is exactly the answer. This is an approximate answer. I have both of them down, so I feel pretty safe about my answer. Okay, you design a football play in which a player runs down the field, makes a 90-degree turn, and runs to the corner of the end zone. Okay, so here's where he starts. He runs down the field here. He makes a 90-degree turn. He runs to the corner of the end zone. So let's go ahead and put a 90-degree angle right there. Your friend runs the play as shown. Did your friend make a 90-degree turn? Oh, okay. So we've got some coordinates here. We've got 60, 50, 30, 20, and 80, negative 30. So I got to see, did this guy make a 90-degree turn? All right, so in order to do that, I got to calculate three distances. This distance, and this distance, and then plug them into the Pythagorean Theorem to see if they work. Okay, so let's start with distance 1. Distance 1 is going to be the square root of 60 minus 30 squared plus 50 minus 20 squared. Okay, so distance 1 is going to be 30 squared plus 30 squared, which is going to be 900 plus 900, square root of 900 plus 900. So that's the square root of 1800. Now, I can turn that into a decimal, but I'm going to leave it just like that because that's an exact answer, okay? And that's going to be a little bit easier for me to deal with in the next step. So just leave it like that. And let's go on to the next part, okay? So here's D1. Whoops. D1's in blue. All right, now let's calculate D2. So here's D2. All right, so D2 is going to be the square root of 80 minus 30 squared plus negative 30 minus 20 squared. So this is going to be 50 squared plus negative 50 squared. So this is 2,500 plus 2,500, which is going to be the square root of 5,000. Okay, so I'm going to leave this just like that. I don't think I'm going to have enough room to do this problem. What do I got under here? Yeah, I'm going to have to move this, so bear with me here just a second. All right, that gives me a little more room. Okay, now we're going to go up here and calculate D3. So D3 is going to be the square root of 80 minus 60 squared plus negative 30 minus 50 squared. So that's going to be 20 squared plus that's negative 80 squared. So that's going to be 400 plus 6,400. And that's going to be the square root of 6,800. Okay. So I have now calculated the three distances. Now what I want to do is plug them into the Pythagorean theorem and see if they work. Okay, so the shortest two are these two, so it's going to be square root of 1800 squared plus square root of 5000 squared should equal the square root of 6800 squared. Now you're going to see why I left them square roots, because this gets super easy real quick here, because the squares cancel the square root. This is 1800 plus 5000 should equal 6800, and this is 6800 equals 6800. Okay, so that implies yes, he turned 90 degrees, because that's a right triangle. Okay, so yes, that makes this right here a nice 90-degree angle right there. Now, if you'd turned these into decimals, you would have rounded them probably, and then when you tried to put them in the Pythagorean theorem, they might not have come out to be exactly equal, and you might say, well, it's pretty close, but it wasn't 90 degrees. That's one of the advantages in using exact answers. Okay, so here's what I want you to do. I want you to calculate the distance between the 2 points in problem A and problem B. So pause the video here, do those two problems, and then jump back on and see how you did. Okay, so we're going to write down our distance formula. It's the square root of x2 minus x1 squared plus y2 minus y1 squared. It's going to work for both of these problems, so I'm going to go ahead and just do this one here. So the distance is going to be the square root of -5 minus -2 squared plus 1 minus -3 squared. Okay, so these become plus right here, and so do those. So this is going to be -3 squared plus, this is 4 squared. You might be able to guess right now what this is going to be, because it's a Pythagorean triple. 3, 4, and the other one's going to be 5. So this is going to be the square root of 9 plus 16, which is the square root of 25, which is 5. You're going to notice the distance is always going to come out to be positive, because distance can't be negative, right? You can get down to 0 distance, but you can't make it negative. Okay, now the B one. Distance equals the square root of 9 minus 7 squared plus 6 minus -3 squared. Now keep in mind, these don't always come out to be nice numbers like 5, okay? So this is 2 squared plus, this is 9 squared. So this is the square root of 4 plus 81, which is the square root of 85. Now that's not a perfect square, so I'm going to get out my TI-84 and I'm going to square root 85. And that's going to be approximately 9.22. Okay, so like I said, they don't always come out to be nice numbers. All right, so hopefully you got square root of 5, or I'm sorry, you got 5 and the square root of 85, or 9.22. Okay, you're going to get to do 1 through 29 odd, and I'll see you guys in class tomorrow.